And basically, we start this very, the most important part about this course. So far we have discussed some basics and we have discussed technology, okay? Well, plus some types of information systems. Now we get into real business. Basically, how they are designed, how they should be designed. Okay? What in this course you will design a database for a information system. Not just database, you will design also software blocks. You will also kind of interface, okay, and reports and forms and all this stuff. So it's not just the database that we're doing here. So now you have to pay real attention, okay? Every detail is important. Here. So in the first chapter we'll basically we talk, just give me one moment. We'll talk about, specifically database accounting information systems, right? So we'll compare them to the old systems that used files. Okay, and we talk about advantages and disadvantages of both. Just maybe let me actually start first with syllabus. Okay. So today we have a lot of technical problems, so particularly is warming up. But basically what I want to say is that next time, very important, it's not just homework, okay, and it's not just quiz. Before the next time, you have to decide on project group compositions. Okay? So that's all you can have groups of for your project up to 2, no more than 2. Okay? So what you do, you will find someone here with whom you would like to work with. You write me an email saying, well, we would like to form a group. I am the student, the person, right? So we would like to form a group. So
we can work alone if we want, right?
Yes, if you really want to, you can work alone. That's totally fine. But if you want to work in groups, you'll work in groups. So let me tell you the idea behind why it's great to work in groups. Well, it's not really great. Some people don't like it, right? But when you get a job and when you will work out in the field, right, you will work with someone else. Okay. So you will have to cooperate, right? So teamwork is important. This is strange. Anyway, let me try to connect my laptop. Meanwhile. So right now. So before we discuss, right, that we have this, information systems, and probably by now you understand that, well, you cannot do everything by hand, right? So if you work at a multi-million company, so you need to have some kind of information systems in place, which would be computerized, okay, finally, and which would basically process transactions for you and do other stuff for you, right? Not just transactions, it should be also any business events, any relevant business events should be captured, processed, and reported by such a system. Okay? So, what system are there? Last time, well, not last time, chapter 1, right, so it was a quick introduction, so we talked that basically have the systems, those old systems, right, written in COBOL language, common business oriented language, right? So, basically what they try to do is they try just to automate what people would do. What we said is in this course, okay, we will discuss the so-called database approach, where we don't try to automate, we try to reinvent information system. So we make this integrated database which captures all relevant business events. Okay, and we talk about advantages and disadvantages of such a business system. So first I will show you basically, so we'll discuss this question a little more, and I will show you some common problems with those old systems that used files instead of databases. Okay, good. So let's start. So do you remember what was the problems, with this old cobbled programs, right? In 80s, 90s for accounting. So do you remember some problems which we discussed before? Just one. Yes, they would. Yeah, correct. So they were transaction oriented, right? They didn't take into account business events. What else? They're integrated. Integration is very important. And do you remember why they're not integrated?
It has a different database for everything.
So basically, what Omar was trying to tell that they each program, right, each application has its own kind of database, right? Has its own kind of files. It has a proprietary file management system. Okay, so only one program could access those files. If you try to use other programs to access the same files, well, you cannot. Okay, so they're kind of independent. So there are many independent programs, and this creates a problem. So let me show you how it works. So basically, you have well, say 3 application programs, right? And each has its own set of files. So these programs are independent. Okay, anyway, and you have users, well, for each of those applications. And just to give you an example, well, suppose that you want to have an application 1 is designed for sales, to process sales, right? So your application process sales. It needs to access some files. Okay, what files should it access? What do you think? So you are selling. So you are selling something, right? You're a retailer, right? You're Walmart. What files do you need? Okay, so Matt just said that you need information about customers. What information about customers?
Address.
Yeah, but why do you need this information? Okay, so you're selling something. Maybe not Walmart. Walmart is a bad example. Think about big companies that often do what? Wholesale. That's true. Well, think about business to business kind of transactions. Why do you need information about customers? Did you know that? Mention the one. So what type of sales are there?
Sales on account.
Yeah, so that's all sales on the account, right? So if someone's paying cash, in the store, well, maybe you don't need information about the cost, right? But if someone is, if you are selling basically on credit, right? Then you need some information about cost. Okay, since you should know who you will bill. Okay, so we'll have some file where we'll have information about customers. Okay, basically the credit balance, the balance, the address, the name, and so on. What else do we need? So you are selling computers, right? So what do you need to know? Order comes in. Let's put it this way. So what do you do? Inventory. Right, you need to check if you have a specific model or whatever device in your inventory. Okay. So one file is inventory, right? The other one is files about customers. What else? Sales. Of course. So suppose that when you sold someone something, right? You need to report this sale. Okay. So you'll have a file for sales. So basically, suppose that you have 3 files, right? Maybe more, but for now let's keep it to 3. So file A would stand for inventory file, file B would stand for customers file, and file C would stand for sales. You need to report sales. Okay. Then you have application program number 2. Okay, so suppose you sold someone on account. What should you do then? You know, the transaction didn't end, right? You sold someone something on account, then what? You want to
Post.
mail a button. But think about, you know, in terms of business process. Okay, you got business side. Okay, so today I sold you 100 computers on account, right? On credit. So you need to bill someone, right? You need to collect money, okay? So the second, say, application would be collections. Okay, accounts receivables. Right, so you have to collect money from your debtors, right? From your customers. So what do you need for that? What kind of files do you need for that?
Outstanding balance.
So information about outstanding balances of your customers, and where would you get such information? What should be the file? Yeah, correct. Well, it's not really accounts receivable. So it would be the same file as here, file about customers, right? Which would contain information about customers, say balances, and so on. Right? So the same file, file B, customers file, you would have for application 1 and application 2. Okay? Okay, so suppose now, again, you are this retailer, right? So you're, well, wholesaler or whatever. So you are selling inventory. So in order to sell something, you need what? You need to, well, not the inventory. No, I'm saying application 3, right? Would be another business cycle important for retailing.
Like a point of sale.
Wait, repeat the question again. What is the question?
So we're not talking about this basically business cycles, right? This business processes. One would be sales, right? So you sell something. Another would be accounts receivable, so you collect collections, right? That's money. But in order to sell something, you need what?
Inventory?
You need to have inventory, okay? So where do you get inventory?
Purchase it.
Purchasing, right? So you need a purchasing application for purchasing, right? You need to purchase inventory, okay? So if you have such an application for purchasing, so what file do you need there? Okay, vendor is one file. Okay. That is correct. You will need information of vendors. What else? So supplier vendors. What else?
Can you repeat the question again, please?
What kind of files would you need here? What kind of data you would need?
Purchase orders.
Purchase orders. This is correct. You would need information of vendors and the most important one. Yeah, I would say vendors, purchase orders, and there's another one which is also very, very important. It's not even big. Well, this is very simple. You will need inventory file, right? So you have to report, right? So again, so we got inventory file here, file A, and again here you have file A, which is the same inventory file, right? But what we just said in the beginning, that those programs are independent, okay? So if you have file A here, this file A cannot be accessed by application program 3, okay? It can only be accessed by application program 1. So here file A, inventory file, and here inventory file, they are different files. They are different files, okay? So moreover, they can have a different structure. For example, here you can have description of your inventory, right? You can have a field with description, and here, well, you cannot have such a, well, maybe you don't have such a field in this file. So they can have different fields, okay? Different files, different fields. The same is with customers. You have customers here, you have customers here. So two files which should essentially store the same information, but they're different files and they can differ somehow. And what do you think? What is the worst case scenario? Say about customers. So you have two files about customers. So it can be the worst case scenario. So you sold something. You doesn't pay you. But okay, but suppose
like,
they want to pay.
what
Suppose they
if
want
he
to pay.
had he complained about the first thing and you didn't notice that and
I'm not sure with that. Oh, suppose they're correct. Well, you said it wrong. Okay, so it's in some sense. Suppose that there's a customer, right? Your customer changed an address. Okay, so this address or telephone number, whatever. So this telephone number, say they changed it while they was purchasing something, right? Customer pre once there was a sale, they told you, well, I changed my number. So there will be changes in file B here, okay, but those changes would not automatically be made in file B for application program number 2. So when you would like to collect your money, you call the number and nothing, okay, or the address changed. So it can happen. There can be data inconsistencies. This is very, very serious. It happens even today. Okay? It's a huge problem, and this is how many companies lose their money. Okay. So what can happen? Okay, so you have two files, and they differ. They have different information. And what is bad about all this, right? That you don't really know what information is correct. You have two different phone numbers. Which one is correct? Different addresses. Which one is correct? Who knows, right? So this is a problem. Well, suppose now that again you have information about customers, you would like to add a new field about customer. No field. Well, let's say balance. Also, balance should be essential field, right? So if you like to add a new field about about customers, it's not easy to do it. It's not easy at all. Okay, you have to change the application itself. The description of the files, right, of the fields, is stored in those application programs, not here. Okay, so if you want to make some changes, it's very, very hard. It's very hard to do it. Okay. So basically, what are the problems with this? Problems are you store the same information several times. Basically, data redundancy. But forget about this. Maybe not the worst problem. The worst problem is data inconsistency. Okay, you have the same files which should reflect the information, and they differ. Okay, so there is a conflict between information. This is the worst. Then it is hard to create a new application here. Okay, since or change application. Since if you modify a file, you have to modify the application. Okay, so this is also a huge problem. So here you have those problems, and well, so if you want if you want to make a new application, right, you have to develop a new set of files. You can't use the old ones. So it will take you some time to develop a new application. So it's also lengthy application development. So you have this at least 4 disadvantages of such system. Very serious ones. Okay. So how is it different from this kind of database perspective, right? You use database approach. Well, let's see. Let me show you this figure. It explains everything. So the idea with database, then you have a database, right, where you have data sets. So basically, it's not really files, now we call them data sets, okay? So each data set contains information about customers, about sales, about inventory, purchases, and so on and so on, okay? So you have just one database, so you don't have any duplicate information, okay? Each information is stored once. Well, aside from backup, okay, you make backup, okay? But in your operation, just use one source of information from your database. Okay, so database is managed by a special software called Database Management System. So if you use computers right a lot, so what may happen, for example, suppose you open a file in Microsoft Word. Okay. It's open, and then you forgot that you opened it in Word. So what will happen if you try to say rename the file?
gonna tell you that the file is already open, and you're gonna have to.
Yeah, it will tell that the file is open, right? So you cannot change it. Okay. So essentially, what it means that basically no two applications can at least write to the same file. Okay. So only one application can open file in this write mode each time. Okay. So this is very important. So here, even if you wanted to, use two applications to open the same file, there would be a problem with access. Application 1 would open the file, and application 2 would be blocked out. Okay, it couldn't write to that file, so that'd be a problem. Here, what happens? That you have this application, database management system, okay, and it controls everything. So basically, on some level, it allows simultaneous access to files. Okay, so there's something called concurrent control, concurrent access. So this database management system basically manages this access. So that each application is connected to the database management system, and basically, so when you want to make some queries, right? When you want to do something with data, everything goes through this database management system. So previously, this old approach, right, file approach, would happen that, as I told you, each application would define the structure of the data, right? So if you say use a new field or change the data structure, then you would have to change the application itself. In the database approach, so the database contains data structure. Okay. So there is something called data dictionary, and it is stored within the database. So basically, data and description of the data is stored together. Okay. Previously, data was stored separately, and description of the data was stored in the application programs. So now, what is great about it? If you say want to write a new application, okay, so you don't have to define data structures application. So data structure is defined here. So now, if you want to write a new application, you don't have to create new files for this application. All the files are here. Well, maybe you need to create one or two, but if you need to use some existing files, you can do it. Okay, you don't have to create copies of those existing files. What is also great, which is both advantage and disadvantage, right? So basically, here's everything centralized. So if you want to have a database and all your information about your company secure, well, you have just to secure this link. Okay. So, for example, suppose you have employee file, right? And you don't want you want only some people to have privileges to view the whole file, right? Employees, including social security numbers and so on. Okay. So if several applications would use this employee file, then you would have to install these controls, right? You would have to install these preventive measures in those applications. Okay. Now you have to do it only once. This is database management system. So basically, you can define who can access the system and who cannot access the system. Okay. So what is the? Well, this is a great advantage, right? So it's easy to control access. But what is the disadvantage?
Easy to use some fun.
So again,
Easy to use, yeah.
you make backups. So suppose you have backups. No, I'm saying that, well, basically, this is kind of centralized application, so everything goes through here. So it defines access, right, to data sets and so on. So I just told you one advantage is that, right, since this is centralized, you can you have to define data access only once. Okay. So, for example, if you want only top managers to see employee files, well, you do it only once. You don't do it in each application. What is the problem?
Somebody breaks it, then they get everything.
Yes. If somebody hacks this, they get everything. Keys to the kingdom. Okay? So they have everything. So well, you have to make it very, very secure. Here you, well, someone would say break application 1, right? They would get access only to the files APC, but not to D, not to E, and so on. So here, if they would break this, they would get access to everything. Okay. So both advantage and disadvantage. So here you can see the advantages, right? So what advantages? So you store information only once. You don't have data redundancy, right? You don't have data inconsistency. Again, since you store information only once, then what? Then you have this data independence. Data is independent of the application. Since, as I told you, everything is defined. Data structure is defined in this data dictionary, right? So, so if you want to design new application, it's not this much easier, since you don't have to think about data much, right? As part of another, to add some new part of the database, but otherwise everything is there. And finally, you have a centralized system which does the control and can backup data and so on. Questions? Guys, please ask me questions. So it's a good idea to ask questions. If you don't understand something more, you want to know more about something. No? Good. So what are the disadvantages? And there are disadvantages. First of all, this is very, very complex software, right? So basically, this is kind of a ERP, Enterprise Resource Planning System. Okay, so it costs a lot, and it's very hard to customize. And the maintenance of such system, right, and support also sometimes costs more than the system itself. So very hard, very complex system. So this means that you have to, you need to incur some costs, right? You have to have people who know how to work with this, right? So if you're a company, you need to hire those professionals who knows how these administrators, right? Database administrators. Okay. So what do you think? What does it mean for you as an accountant? That they have such a system in place. And so all big companies have. So you are an accountant. Yes. So you have to know how to work with such, yes, you have to know how it works, and you have to know how to work with it, right? So you have to know how to create queries, for example. If you're an auditor, you need to know even more. You need to know how the dictionary is organized, how to extract data, okay, how to manage data, and all the stuff. So it requires some extra knowledge. Okay. So another drawback that I told you is basically this security issue. So if someone breaks your software, that's it. So these are the problems. And another problem is, suppose you want to develop some application which would, access database management system. So even if it is a simple application, it will be very complex due to the thing, right? So you have to create these interfaces between application and between systems. So it might be a problem. So basically, all problems come from complexity and centralization. These are the problems. Good. So you have advantages and disadvantages on this slide. So let's now talk about, let's go back and talk about databases more and tables, right? So remember though, in chapter 2 we discussed that, you have this data hierarchy. So you have bit, which is 0 or 1, you have byte, right? This is 8 bits. You have field, which is a collection of related bytes. So field can be a name, right? Value, balance, whatever. You have then a record. So record is a collection of relevant fields, for example, employee record, sales record, so on, right? Then your collection of relevant records creates a data set. So data set of employees, vendors, sales, purchases, and so on. Finally, related data sets, right, to your business, for example, form database. Okay, so hope you remember this. So let's talk about something which we talked about before, which will be very important in this course. Told you are those keys. Primary keys, composite keys, secondary keys, and so on. So what is the primary key?
Uniquely identified.
Unique field that uniquely identifies a record, right? It's called the primary key. What is composite key?
You have two unique ways, right? When there's a composite,
More than one primary.
two or more.
Yeah, but primary keys consists of several fields, right? It's called the composite key. Okay, good. So all other keys that are not primary keys are called non-key attributes. So what is very important in this whole business is something called foreign key. So what is a foreign key? So a foreign key is a key which is a primary key for some other table. Let me give you an example. Suppose that you have sales, right? So you have a table for customers and you have sales tables, right? So this is what you set as of customers. So in your sales table, you would have basically a sale order number, right? You would have maybe amount, you would have price, some information about inventory. You would have information about customer. So most likely you would have customer ID there, right? So customer ID does not uniquely identifies a sale. Why? Uniquely. So you can have the same customer basically having several sales, right? Okay, but customer ID is a foreign key. Okay, so what's a foreign key? Because we have another table with customers. Okay, and in that table, customer ID is a primary key. So such keys are called foreign keys. Okay, so it's extremely important. Okay, questions? Guys, it's clear. What is a foreign key?
Yes.
Good. So another important concept for us: relationships. What is a relationship? Well, one way to think about it. So you have tables, right? You have these tables. And tables can be in relationships with one another, right? So somehow they are connected with each other. For example, customers and sales. Okay. And there are several types of relationships. First of all, there is something called cardinality. This is what you see here. So there are three types of cardinality: one-to-one, one-to-many, and many-to-many. So what does it mean? For example, let me give you this example with sales. You have customers and you have sales, right? So how many sales can be assigned to one customer? So one customer can make several purchases, right? There can be several sales, okay? However, each sale has just one customer, okay? So this is called one-to-many relationship. So for each sale, right, you can have one customer. For each customer, you can have many sales. Yes.
Isn't that like if you are making a relationship in the same table, then that relationship would be one-to-one relationship? Yeah, also you could
One-to-one is, for example, when you have a department and you have department chair, right? So each department has one department chair. Okay? Each department chair belongs only to one department. Okay? So this is an example. Or for example, you have another room. Well, that's a good idea. So basically, you have rooms and you have room numbers, right? So each room should have a room number, okay? And each room number should have a room. Okay? You can kind of have room with more than one room numbers, okay? You can have more room number which is assigned to more than one room. is in the building, in one building. Okay. So one-to-one is when you have two entities, two events, whatever, two tables, and each record from one table can have no more than one record from another table, and vice versa. Okay. One-to-many is when you have when you have again two tables. Each record from the first table can have many associated records from the second table. Okay, but each record from the second table can have only one record from the first table. Okay. For example, another example would be sales and customers and sales representatives, right? So if you have, suppose you have a business, right, and in your business you decided that each customer should have a salesperson assigned to it, right? And this salesperson would always serve that customer. In this case, the relationship is one-to-many. So for each customer, you have no more than one salesperson assigned, right? I'm sorry, actually this would be one-to-many. So for each well, let's go this way. For each salesperson, right, you can have many customers assigned, but for each customer, you can have only one salesperson. Okay, you can have another scenario. So in this case, you can have you can decide that each customer can have many salespersons assigned to him, and each salesperson can be assigned to many customers. This would be a many-to-many relationship. Okay. As questions. We will see examples, but questions at the moment. We'll just stop it. Yeah. We'll just see more examples of this. Say again?
Can you explain many to many?
Yeah. Many-to-many is when you have two tables. Okay. Each record from table 1 can be associated with many records in table 2, and each record in table 2 can be associated with many records from table 1. Okay. For example, students and courses, right? So as a student, you can be assigned to, you can take many courses, not just one, right? You can take many of them. And each course typically will have more than one student, right? So have many students. So this will be a relationship many-to-many. And what's important also here, so one-to-many is it's directional. Okay, so basically what I'm trying to say, you can have either one-to-many or many-to-one. All right, so one is M is different from M1. Okay, so let me give you an example. So if you say that, let's say I have again customers and salesperson, right? So if customers and salesperson is one-to-many, it means that for each customer you can have many salesperson, but for each salesperson you can have only one customer. Okay, so customers sales, let's say salespeople. Okay, so you have one-to-many relationship between customers and salespeople. It means that each customer you can have more than one salesperson, and for each person you can have only one customer, which doesn't make sense, right? So a more appropriate relationship would be M-to-1. For each customer you can have only one salesperson, but for each salesperson you can have more than one customers. Okay. If I were to switch the words around, if I were to say, well, what's the relationship between salespeople and customers? Okay, then the correct relationship would be one-many. So basically, what I'm trying to say is there is a direction here, and again, this will be an example, so I think it's easy to see on the real examples. But are there any questions so far? No. So what we study here is database approach, right? However, there are several database approaches. Okay. And what we will discuss in this course is probably the best database approach out there, which is relational databases. Okay. So why it's called relational? So there was a professor called who worked for IBM in the 60s or 70s, and basically what happened that he developed this model. Okay, this model is very, very sound. So you will see how it works. This is a very sound model. However, it was not implemented until the 90s. And do you know why? Well, the reason was, this is a great model. Everything looks nice, but it is well, you have a very powerful computer to use this model. Okay, so it requires a lot of computer resources, and at that time when he developed it, no one could use it really. So they built some test, some kind of proof of concept applications, databases, but you couldn't use it on a large scale for a large company. So nowadays it is possible. Okay, so that's what I'm saying. There are other types of approaches, but this is one probably the best. And now we can use it due to technology. Before we couldn't use it. Okay. So why it's called relational model? Well, it's simply because he developed this kind of mathematical model, right? And he called a table a relation. We'll still call a table a table. Okay, we will not call it relation, but basically he called table a relation. And what is a table? Table is something which has rows and columns. Okay, so think of what we discussed before. We have this records, right? So which would be your rows, and columns would be your fields. Okay, so this is a table. It's a two-dimensional table, rows and columns. Table that you're more or less used to. Okay. So rows are records, right? Also tuples. We'll call them records. Columns are fields or attributes. So we will use both fields and both attributes, right? Doesn't matter. And now there are proliferation of various databases that use relational model. Okay. So what is first let's look at this example before we discuss what are the assumptions with the model. So here we have an examples of various tables, right? There is a table for sales regions, table for customers, table for sales orders, items orders, collections, orders collections, and items. So basically, this is tables. These are tables related to sales. Okay. So if you sell something, this is probably what you will need to have. Okay. So items are basically inventory. Customers are your customers, which you usually sell an account, right? And then this information about sales orders, this information about what items were ordered. You have collections, order collections, and you have in which regions the sale was made. Okay. So you can see this. First of all, you can see that some fields are underlined. Okay. This basically shows that those are primary keys. Okay, if you see a field which is underlined, this means this is a primary key. So for customers, customer number is the primary key. For items, primary key is item number. Okay. So what are the arrows? Arrows basically shows us these relationships, whether it's one-to-one or one-to-many and so on. Okay. Actually, here are one-to-many. So if you see that one arrow, right, one triangle, it means one. If you see two arrows, double arrow, it means many. Well, for example, and I forgot to tell you this. And also you can see this asterisk, right? So those indicate foreign keys. And you may notice that those links, those arrows, right, between primary keys and foreign keys, right? So I told you that foreign keys are used to link tables. Okay. So and this is how we link them. So we use foreign keys and primary keys to link tables. Questions?
Professor,
Yeah.
the asterisk represents like
A foreign key.
foreign key.
Okay. Yeah. So let's discuss this. Let's look, for example, at let's look at this sales orders and okay, let's start with customers. So you have information on the table about customers, right? Customer number, name, address, balance, credit limit. Customer number is a primary key, okay, since it uniquely identifies a record. This is a primary key, right? Customer number is a foreign key in these sales order tables. And what is a sales order table? Sales order contains information about basically orders, okay? So this is orders table. So there's order number, order date, customer, order amount, and region. So the primary key here would be order number. So can you explain me why, say, date or customer number or order amount or region could not be primary keys? Primary keys for sales orders.
You can have any sales order in one day.
You can have, you're right, so you can have several sales orders on the same date. You can have several orders, yes, with the same customer, the same order amount, and the same region, okay? Only order number is a unique piece of information. But customer number, okay, is a foreign key. Why is it a foreign key? Because it is a primary key in this table, okay? And this is how we link two tables together. This is how we have this great link between customers and sales orders.
There's also the link between foreign key and primary key of the table. Foreign key always has to involve in the relationship.
Yes, I'll talk about this here, but basically yes. Okay. So and then you also have a region number. Okay. So region number is also a foreign key. Why?
It's a primary key of sales region.
Because region number is a primary key for sales regions table, right? So this is a foreign key, right? So foreign keys are those keys which are not primary keys in this table, but which are primary keys in some other tables. Okay? Those are foreign keys. Good. And you can see that between foreign keys and primary keys, you have this arrow which signifies relationship. So one triangle means one, two triangles means many. So if you look at this customers and sales orders, right? What would be the relationship between customers and sales order? It will be either one to one, one to many, many to one, or many to many. So what is the relationship between customers and sales orders? What do you think?
One to many.
One to many. Why?
One customer might have many.
Yes. And?
Many orders could be forward.
No. each order should have only one customer. Okay? Well, no more than one. I'll put it this way. Okay? Good. So here, well, let's have this, but here you don't see explicitly one-to-one relationships, right? Maybe there are some, but you wouldn't see them. Yeah.
Would receipt number and order number be one to one or no?
Receipt number
And order number?
and order number. This, right? So this is actually a good question, and I'll talk about this. But why I will talk about this later, right? Well, in a few minutes. There is no direct link between them, right? There is no yeah. So there is no arrow that would connect those two, right? Collections and sale orders. But clearly they are connected, and we'll discuss this in a moment. Okay. But before we go there, right? So so just name quickly what kind of one-to-many relationships you can see here. So starting from the top. So what kind of relationships one-to-many you see here?
Sales region, sales orders.
So sales region, sales order, one-to-many relationship. For each sales region, you can have many sales orders, but each sales order belongs to just one sales region, right? Good. Then what?
Customers to sales orders.
Customer sales orders, which I just covered. Good. Then what?
Items, item orders to sales orders. Like sales orders to item orders.
So sales orders and item orders, right? So for each sales order, you can have many items ordered. For each items order, you can have just one sale. So it's one-to-many, right? So sales orders and items ordered, one-to-many. If you were to say, what is the relationship between items ordered and sales ordered? It would be many to one. Okay, the other way around, many to one. Since I named it first, right, before this one. So it's direction is important. Okay, good.
Customers and collections.
Customers and collections. Again, we'll talk about this soon. So basically, you can name all these one-to-many relationships, right? So there is between what else? Sales order and orders collection, one-to-many relationship between collections and order collections, and between item and items ordered, right? So this is one-to-many relationships, right? So here you don't see one-to-one yet, and probably we'll discuss it next. Is the next chapter. Well, in chapter number 8, not the next one, but later. But here there are many-to-many relationships. Okay. So they are here. Can you name a many-to-many relationship here? Let's just look at this.
Sales orders
And items. Good. So whenever we want to have this many-to-many relationship, right? We we can just use foreign keys in those tables, right? So we can put a foreign key here for a sales order. Okay, and again we'll discuss why. So what we have to do, we have to create those special tables. So have items and sales orders. So you create a special table, okay? And this table should have a primary key, which is composite key, okay? And each part of the key is a foreign key of your tables. So you take items, you take this primary key, you make it foreign key here. You take sales orders, you take primary key orders, which is a foreign key here, and you take this pair and you make this pair a composite key. Okay. So how does it work now? Let me explain. So for each sales order, okay, you can have many records from items order, okay, and from each items order you can have one item, right? Let me show. So easy to illustrate. So you have a sales order record, right? For this sales order record, you can have more than one record for items ordered, right? IO, right? For each items order, you can have only one sales order, right? And then for each items order, you can have no more than one item, right? Let's say one item. So there is this indirect relationship between sales orders and items, okay? And here, if you look, right, so for each sales order, you can have several items, okay? Through this composite key. So because each sales order can have several records from items order, and each items order have one record from items, right? You will have one-to-many relationships between those. So you have basically one-to-many relationships between those two, right? And this basically for each order, right? Well, you can see directly. You can have several items numbers here, right? So this is a one-to-many relationship. So you have many on the side of items. Then you take it the other way around. Now you look at items. Now we go back, right? Now we look at items. Items. So each item can be related with several items ordered, right? And each item ordered will be in relationship with one sales order. Again, you have this many relationship, right? So for each sales order, you can have many items here, right? So it's one-to-many relationship. For each item, you can have many orders, right? Here. So this is why you have many relationship, many-to-many between sales orders and items. So when you want to have this, many-to-many relationship, you have to create a separate table for this relationship. Whereas the primary keys would create a composite key here, okay? And so this key was a composite key, and each field in this composite key are foreign keys to the appropriate tables. Questions? Again, we'll discuss it more in chapter 8, but what's important for you to remember. Whenever you want to have many-to-many relationship, you should create such a table. Let's say call it artificial table for now, okay? Questions? Okay, so there was a question how, say, customers are related to collections, right? Or something like that. Okay. So there is no direct connection between customers and orders collections. So what is the relationships between them? What do you think? What should be the relationship between customers and order collections? One to many. Why?
Because one customer can make many payments on item order.
Very easy, right? So one customer can order several times, right? There can be several sales order, right? And then sales order can have several collections, right? So you have kind of one, many, and again many. So it makes this one to many. It's not direct, but basically from this you can infer this. Okay? Since one customer can have many sales orders, and then sales order can have, well, many, even if it was one, doesn't matter. So, because sales order is connected to collections, right? You can deduce that one customer can have many collections. Okay? So this is one way. So the other question, more interesting one, is how many collections can be assigned to. No, I'm sorry. So for each collection, how many customers can there be?
One.
One. Why? Again, just looking at this table. This comes with this practice, but let me tell you the way to think about it. For each collection, right, you have just one sales order, right? And for each sales order, you have just one customer. Okay? So let me say it again. For each collection, you have one sales order. And there's only one sales order as one customer related to this sales order. Okay? This is why for each collection, you can have only one customer. Yes.
So say for example, if you were given a situation like this, you would have to infer based on what the leading points are.
Yeah, basically you can infer this. No, actually, this indirect relationships, right? It's not covered in the book, to tell the truth. So, but you asked me how it works, so I just explain. So, your project would be slightly simpler, right? I wouldn't ask you, well, what are the relationships between those? But you just have to know, right? So, everything here probably is connected, and you can infer all relationships if you really want to. But it's not essential. For you, what is essential is to create these direct relationships. And once you have direct relationships, those indirect ones, which where I jump basically, right? Those will be created automatically. You don't have really to think about them. You don't have to check if they are valid or not. If your direct relationships are valid, then everything will be fine. All other relationships are also valid. Okay? Questions? Guys, questions. Ask questions. Very important. It's okay. Is it clear or not? Should we talk about this more? What do you think? Talk more.
Do you have any exercises that we did in chapter 2?
This is not the focus of this chapter. So we'll talk more about this chapter 8. So we'll get back to this, right? So this is more kind of introduction to the topic. But
So are we going
But-
to see that on quiz?
I don't think so. So
Or the final.
Sorry?
Quiz or final is the second.
yeah, this might be on the final. But by the time you get to final, you will have to do it by yourself. So you will learn this. Don't worry. Well, you will have to learn this if you want to pass the exam. Again, so this is I told you that this chapter you should read twice, 3 times or something. Okay, you won't be able to memorize and understand everything from the first time. So read the book. Now, let me quickly go over again about all of this, right? So you have some tables which are related to sales and collections. Okay, so you have tables for sales regions, customers, blah blah blah, and so on. So here, for example, you see the name of the table, right? Then you see the fields. So for sales order, you have fields order number, date, customer number, order amount, and region number, right? So fields which are underlined here denote primary keys. Okay, those unique identifiers of records. Keys, fields which have this asterisk, right? Those are foreign keys. A foreign key is an attribute which is not a primary key here. Well, it can be a primary key, but it shouldn't be. Well, it's not supposed to be primary key. But this is a field which is a primary key for some other table. Okay, so customer number is a primary key for customers table. Okay, it's a unique identifier for customers table. Good. Then what? Then you can see these relationships here, those arrows, right? So if you have this one triangle, it means one. If you have these 2 triangles, it means many. So between customers and sales orders, you have one-to-many relationship. Okay, which means that for each customer you can have many sales orders, but for each sales order you can have no more than one customer. Okay, so basically those arrows that you see here, you don't need them. Okay, so no one really advises those arrows. Arrows it's just for demonstration. That's just for you to easy to grasp. So the idea here is to show you what kind of tables they can be and how they're connected. Okay, so no one really draws those arrows like here, but there are those connections, implicit connections, right, between foreign keys and between primary keys, and they show you how it works. So you can see all these one-to-many relationships or many-to-one. So it depends, from what side you read, right? What is important here is that if you want to have a many-to-many relationship, right? For example, you have items and sales. For each sale, right? Each sale can have one sale can have more than one items, right? You can sell more than one items, okay? and an item, for example, this particular laptop, right? Several orders can order this item. Okay, you can have several people who should order this laptop, this type of laptop, not the instance, right? Not the exact, physical laptop or monitor, but this type of monitors, right? Your inventory. Okay, so have this many-to-many relationship. So for each inventory item, it can be on many sales orders, and each sales order can include more than one inventory items. Okay, so the way to have this model, this many-to-many relationship, right, is to create a special table. In this table, you will have a primary key, which consists of primary key from one table, order number, and from the other table, item number. Okay, so this is a composite key, which consists of primary keys of these two tables where you have many-to-many relationship. Okay, so you can see that those fields in this composite key are foreign keys. Why are they foreign keys? They are foreign keys because order number is the primary key in sales order, and item number is the primary key in this items table, right? So we create such a table specifically to model this many-to-many relationship. Okay. Sometimes this table, is just this key and that's it. Okay. In this case, we have quantity, order, and unit price. So we have these two non-key attributes: quantity, order, and unit price. But in many cases, we will have just tables like this. And the reason to have these tables is just to have this, model this many-to-many relationship. Okay. In this case, this is called an all-key table. If we don't have, if we have only primary key here. Questions?
What is it called?
Again?
What did you just say?
So sometimes these tables are created only for to model this many-to-many relationship. So this is the only correct way to model many-to-many relationship, right? And therefore sometimes we don't have attributes which are non-key attributes like this, right? Those attributes, they are non-key attributes. Okay. So suppose we don't have them. So in such case, if the parenthesis would end after this composite key, such table would be called an all-key table. All key, everything is key. Okay. Questions? Again, so probably creation of this table is one of the hardest parts of this course, and you will have to do this. Okay. But there are rules. So in chapter 8, we basically will discuss how to do it correctly. So what should be the appropriate design? Design. So again. Yes. You'll have to do this in the project. But this will be slightly easier than this. So you will first create diagrams. We'll talk about this, okay? So first you will have kind of a diagrams, okay, which are easy to and visualize, and then from these diagrams you create those tables. So again, we'll discuss how basically what should be the approach to this, right? You see, one thing with this course and systems in general, there is no one correct solution to many times, right? So you can design systems in many ways. So basically, a project, I would give you a case which would describe, some business, okay? And you will read, how this business works, and you would try to design, to model this business. You would create information systems for this business, okay? And the solutions can be different. They all can be true, but they might differ. But there are some guidelines how to approach this problem, okay? And we'll talk about this.
So, would you also like to go with Steve Horn in there, or?
No, you will have to think about it. So that's what I'm telling you. You have to design it, right? If you will go to to do real work, to do a job, right? And sometimes, design this. Okay, so there will be no cheat sheet, right? You have to do the job. we'll take a very, very simple case, okay? Nothing complicated. So we don't have time for complicated things. Sometimes professors do give very complicated cases, but we don't have time for this. Okay, good. So this is a relational model. Okay, so there are some things which are essential to all this to work. Okay, there are some rules what we need, right? So first of all, we have the tables, right? Each table should have unique names. So does it make sense for each table to have a unique name, like items, order, collection, and so on? What do you think? The statement is each table should have a unique name. My question is, does it make sense?
Yes.
Why?
If you don't want to look for two different fields in front of each other.
You don't have to have two tables that may be inconsistent, right? You know which one to use. You want to have one table with one unique name. Good. The same with fields, right? So when you have fields, each field should be unique. Does it make sense? Field name should be unique. Yes, again. So you have a collections table, and suppose you would have two total amounts here, right? So which one you should use? Maybe they have different values. So each field should be unique. Field name should be unique. Good. Now, the next thing is that next rule is that each row, each record should be unique. Does it make sense or not? Why?
No, because you don't want to have like two addresses, like, you know, like, you can't have two addresses, like we can do that transactions.
So
No, for the same,
look,
same time.
again, it doesn't even make sense. Based on what I told you right now, well, not really. So, another piece of information: each record should have a primary key. That you have with this. Each record should have a primary key, right? Since you use it. Now, based on what I told you about that each record should have a primary key, you can infer that each record should be unique. Why? Because primary keys are unique, right? So you can have two identical rows, records, since they should differ at least in their primary key. Okay, good. Then all columns, right, should be unique. Why? Again, this is something which you can infer from what I told you already. Why each column, all columns should be unique? Sam, what do you think? Why in relational tables all columns should be unique? Think. Well, it's harder than rows, but okay, let me give you a hint. So you have a table, right? Column, well, equal column S of everything from top to the bottom. Okay, so don't have a table. Well, okay. So let's talk about that. Basically, column also includes field name. Okay. So and I told you that all field names should be unique, right? So if field names should be unique, you can have the same columns since they should differ at least in the field names. Okay. So the only I think two rules which are very important and I didn't mention right now. Well, one is already mentioned. So there's something called entity integrity. So if you have a record, okay, this record should be unique. It should have a unique primary key, and it should not be null. There should be a value assigned to a primary key. Okay, it cannot be blank. Okay, this is called entity integrity. And please do remember this. It's very important. So entity integrity means that no primary key is null. In other words, each primary key should have a value. Should have a value. Okay. The second important rule is referential integrity. Okay, and referential integrity means that each either null or refer to some value in other table. So what does it mean? Let me explain to you this referential integrity. Okay. You have customer and sales orders, right? Suppose you have a record here, it sales orders record, sales record. So you have a customer number here. Okay. So referential integrity says, so either this value should be null, should be no value at all here, or if there is a value here, then there should be an appropriate record in this in the master table, basically the table where this foreign key is primary key. Okay. This is called referential integrity. Okay, so I'll explain you why. For example, suppose there was a sale, right? And you recorded customer number. So what would happen if you sold someone something, right? You recorded, well, the customer number, and then you look at this customer's table, and there is no primary key with the value from the record. What would that mean? Okay, so you have a record from here, right? Order number, date, customer number, order amount, region. So suppose you have some record, okay, with some values. Then you have a customer number here. And what would happen if the value of the customer number from this record would not be anywhere in this table, in the customer's table? Sorry? No, so referential integrity says, okay, that if you have a record from sales order, then the value of this field should be either null, nothing then, or if there is a value here, then there should be a value in this table, where this foreign key is the primary key. It should be the same value here. Why? The question is why. And the way to think about it, as I just said, well, suppose that you have a record about sales order, right? So you have a record about sales order.
That's in the same case, that's the customer. Otherwise, it's going to break with different customers.
Why two? So we know customer.
So if you have like
Okay, so
If you're making a sales order for a customer that's already in there, then it's already in your customer database.
well, we want this to be a database. But suppose that I'm looking at sales order. Okay, I sold you table. Okay, this class. Okay, so I have your order number, your customer number. Then I pull up my customer records, and you're not there. Okay, so no, you should be there. So this entity integrity means, so if I have a sale, okay, and in my sale record I have customer number, say for Woodley, then Woodley should be in my customers table, okay, record about him. So otherwise, okay, so who would I bill, right? He's not here. I will lose money. So it makes perfect sense. The other part of referential integrity says that this value can be null, it can be blank. So would it make sense here for this to be blank? So you have the sales, you have its records. Would it make sense for customer number to be blank in this table? What do you think? No. Huh? The question is yes. The answer is yes. So you may have some situations when the sale is what?
Return?
No, not on credit. Cash sale, right? So you have a cash sale. Why would you record the cost? How would you create a record of the cost, right? If you have a cash sale or whatever, right? So you have order number, and you don't need this customer in the database. You don't have to build this customer. Okay? So referential integrity says so either values for in these records for customer number are null. For example, it's a cash sale, or if you have a value here, right? Then you should be able to find those customers in your customers table. Okay? So referential integrity. So this is very important. Please remember this. Try to remember this again. Very, very important. But now we'll test your word actually. So should be prepared.
You'll test this one, you said?
Yeah.
Like in the quiz.
So this is important. So please take note of this. Okay. Actually, hold this chapter so this will test you.
Yeah, professor.
Well, this one is very important. Okay. So chapter 6, 7, 8, I think, and 9 are the most important ones.
So in the quiz on Monday, you're going to test us on this particular code?
So, and this is not only in the quiz, it's really also in your project. So that's why it's very important to understand this. Okay. Good. 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 So you have a database. You have this data, right? What you can do databases. So you can. I told you, database can have basically a description of data, right? It's in a dictionary. So you will have a description of data structure in your database. And what you can do, you can deploy basically some kind of a test for your data. Well, one test would be basically a format, like field format. So if it is date, you can put names there, right? So, but there are other tests, so-called data validation rules or data validation tests. So one test is a range test. So what is a range test? Well, suppose that you have people who assign credit limit to customers, right? But what you can do, you don't want them to exploit, their position, right? You don't want to have any fraud. So you would say, well, the credit limit should be between, say, 0, right? You can't make it negative. Should be between 0 and, say, $10,000. Okay, no more. So this would be a range test. This can be sometimes overridden, but say by manager, supervisor. Okay. Another would be validity test. This is something as I just said. Well, you have a date, you can put name here, right? So, or you have a state, right? You have to choose a state, New Jersey, New York, Texas, whatever. So you can make up something. It should be a valid one. Then length test. For example, you have to say input your runner's ID. Runner's ID, I don't know, 10, 12 digits, or whatever it is. So you should input precisely 12 digits, no more, no less. It's a length test. Okay. Valid combinations test. Again, about this credit limit. So a customer has credit limit, right? So say 5,000. So when you make a sale, you can't make a sale more than his credit limit, right? It can be $6,000. So valid combination test basically checks if so you have two fields and they have some relationships, right? They're somehow related to fields. For example, balance and credit limit, or a sale amount and credit limit, right? So you would check that, say, sale amount does not exceed credit limit. Okay, so what's great about databases, so you can embed those to databases. And what are the implications for accounting here? Oh, this is more for audit. What do you think? So you are an auditor, right? You come to well, okay, I'm talking about external auditor. The same is true for internal, but let's talk about external for now. You are external auditor. You come to a company. They have a database, right? And you know that database can have these validation rules. What would you do? You have to what?
That's the information.
You have to check if those rules are in place and if they make sense, right? So, and in a way, this whole database was tried this whole ERP with this changes very much how the list is conducted, right? Nowadays, it's not just enough to look at the numbers, right? So you heard about, we talk about Serbian's Act, right? But one requirement from Serbian's Act is you have to check, this is called control. You heard about controls, financial accounting, even not in the audit class, you heard about controls, right? For example, segregation of duties, all this stuff. Okay, so these are examples of controls. We'll talk controls more in this class later. We'll have a chapter devoted to it. But what's important here is you can embed controls into your database system. And now auditors have to check those controls, okay? You have to check if those controls make sense, whether they install, and so on and so on. Okay, questions about this? No? So, what else can you do? So one thing is to have this data validation rules, right? The other thing is that you want to restrict access to some tables. So I told you that using this database management system, you can control the access. And well, there are two most common ways how you can control access. You can have the key privileges to see particular tables or not. Right? So for example, senior management can look at all employees' information. Okay, or look at some companies' sensitive data. Okay. And then you have low-level employees which would not have such access. Okay. So the other way, the other thing is to create something called a view. So what is a view? Well, suppose that again you have a table of employees, right? So you can hide social security number, you can hide salary, you can hide address, and other sensitive information. Okay? And if you hide this information, then you can allow everyone access to this. So you can have something like a complete directory, right? Where people would find other employees of the company. This is called a view. Basically, you restrict access by hiding some information. Or you can hide information about top executives, right? So you don't want low-level employees to contact your CEOs, CFOs. So you would hide the information and would allow this information to be seen by managers. So this is called a view. Okay. So what's cool about the databases? Again, they basically is that you can just control access, control data input, data processing, and so on. So you can prevent a lot of things. Data dictionary. So you have a database. Database has a description of itself. Okay. This is called data dictionary. So okay, this is also very important. So as we discussed, as we just discussed, you have this database management system, and disadvantages of the system is that it is very complex, right? So you have to know how it works, and more importantly, you have to but very important, you have to know how to work with it. Okay? So you have to know how to access the database, through information, input information, and so on. So to deal with database, we have a special languages in place. Okay? And there are three types of languages. One is data definition language. So this language is used to define the data structure in this way. So we use this language to define the data structure in a database. Data definition language. Okay? So you can, so basically, and this is how you create this validation rules. This is how you control access to your data. The other language is data manipulation language. Okay, so basically this is language how to insert, add, modify records in your database. Finally, which is probably the most important to you, data query language. This is a language to create queries to get information from the database. Okay, and well, there are many ways how you can do this. So in this course, we'll consider 2 ways. One is so-called query by example, which you can do in, say, Access, Microsoft Access. So this is a way where you have a kind of graphical user interface. This. So you can choose what you want, right? So you just click use a mouse. Another one is structured query language, SQL, or as they call it, SQL. So SQL is a language to, well, actually, it can do all of this. It's a data definition language, it is a data manipulation language, it is also a data query language, okay? So you can create reports, extract information using this SQL language. And in Access, basically, you can also use this language. So I'll show you in a moment how it looks like in Microsoft Access. What is also in, and what you will do in your course project, you will create so-called forms for data input mostly. There's a slide that shows you how it looks like. I'll show you in a moment. And you will also create standard reports in Access. For example, for current accounts received or accounts paid. So you can do this. So here's how this query by example looks like. So you have a table. This is Access 2000, maybe 2000. So you have a table for sales orders. You have order number, date, customer number. I'm sure with this one is an amount, right? So suppose you want a query which would output you order number, date, and amount from this table. Okay, it will output you 3 fields, such that the amount of sales order is more than 1,000. So what you do? Basically, this is again this GUI interface. So you say, show me field order number from table sales orders. Show me field date from table sales orders. Show me amount field from sales orders, right? And show me all the records which satisfy this criteria, where the amount of sales orders is more than $1,000. Okay. Questions? I'll show you how to do this. So before your last project, so I will quickly demonstrate you how to use Access. Okay, and how to do all this stuff. But so now, well, we'll talk about this more. Okay. This is what is a form looks like. So why we use forms? Well, of course, forms are kind of this user-friendly ways to input information. So suppose that you have, say, Excel, Excel, right? Suppose that you input records in Excel. So if you would input records row by row, it's hard to do. It's not very intuitive, and you can get lost with it, right? So what you can do, you can imitate paper forms, right? This looks more like a paper form, and you can create new customers or modify this information of customers using these forms. So you can, you can travel through different records, right? So this is called a form. Okay, a form to edit, create content information. So this is a form. Okay. So what we will now do, we will now look at this SQL language. So again, SQL language is a basic language which we will use to create queries. Okay. You can use for all of this, create tables, do manipulation, but we will use to create queries, and only certain types of queries.
In the project, are we going to have to write SQL language too?
Yeah, so we will just, now we will learn a simple statement, and you will have to know it. Very simple. Okay, so SQL supports data definition language, data manipulation language, data query language. Okay, so it does everything. Okay, so what you can do, you can select records which we would learn what to do. Select basically means that you have a table, you want to show records or parts of the records, some fields of records, which satisfy some criteria. Okay, you want to look, for example, at as here. You want to look at all the records where the amount of sales orders is more than $1,000, and you want to look only at those three fields: order number, date, and amount. You don't care about customer number, for example. Okay. Then you can insert, you can add new records, you can update, modify existing records, and you can delete records. Okay. So we will learn select right now. Okay. So how does it look like? Well, this is a select statement in generic forms. So first you write select. Okay. It can be capitalized. Well, it should. Well, it can be not capitalized, but it gets more readable when you capitalize this word. So this is a keyword, right? So select, and then you name the fields which you want to get. For example, select field 1 from table 1, select field 2 from table 1, select field 2 from table 2. Okay, so those are fields which you want to show, which you want to display. So, and the way you identify them. So first you write the table name, unique table name, for example, customers. Then you put a dot, and you put the field name, for example, customers dot customer number. Okay, so this would mean that you want to output on your display customer number field from customers table. Then, for example, you would also want to to output field from other table. For example, I would like to have order number from sales order tables, right? So we have sales order, which sales orders, which should be the name of this table, dot order number. So select this first one. Basically, you tell what you want to output, what fields you want to output, right? Then you have another keyword, from. So from means basically what tables you want to use in your query. You can use 1, 2, 3. Okay. So for example, if I want to have something from customers table, okay, if I'm using customers table in my query, I would write here customers. If I need employees table in my query, I would write employees. If I need a sales table, I would write sales here, right? And all of these are separated by commas. Okay. Then finally, you have where. So where is basically is a criteria. Okay, so you write what criteria you want. For example, you can write where table name 1 common field 1 equals table name 2 common field 1. So what does it mean? It means that we have tables which are linked together. Okay. So we've seen that there are the primary keys and there are foreign keys. Okay. So if you want to combine them, merge them, extract information from merge table, you merge them using this where. Or you can say where amount for sales orders is greater than 1,000. So this is kind of filtering, or this is kind of criteria. You'll see examples. I think it's easier. So this is kind of a condition. So we have one condition. If you want another condition, you write and, not comma. You write and condition 2, one third condition, and condition 3, and so on. Finally, there is something which is optional here. This is why it's in this brackets, right? So it says where to save the results, into what table, but disregard this. Okay. So I think it's easy to see how it works on the example. So suppose you have 4 tables: customers, sales, items sold, right? Okay. And you have this information, and you want to create a query. And query basically you would like to see which customers, if any, have exceeded their credit limit. Okay. Let's see. Actually, I forgot. Let's make a break, 10 minutes break here, okay? And we'll return at 8:30. Okay, and then we'll continue with this. There'll be 3 examples, and I don't want to hold you for 3 examples. Okay? So at 8:30 we continue.
First name is Wilkie, last name is Rogers. 2778. 2778.
Yes.
When are you gonna grade those quizzes?
Great quizzes.
Yeah, those ones.
Today or tomorrow. So.
Will I be able to email to you? Because I'm really curious if I'm gonna do bad on this as well. I'm just gonna drop the class. Because I honestly I just don't understand.
Okay, LMAL is great.
It's like I'm reading a couple times the book, but it's.
Do you take any other courses?
I have international business in the morning, and that since this time, like in the evening, I'm reading, and from like 10 a.m. or 11 a.m., I'm like sitting and reading, and if I'm gonna show you my notes, you will be like surprised. That's why I'm just thinking if I'm gonna do bad on this one as well. I definitely know I did the 2 mistakes.
This class, requires a lot of effort definitely. So.
But it's not that like I just like look at the book and look on the slides and it's over. I'm reading every single word. I'm like write it down in the slides, like the missing information and how it's work. I just
Well,
You know,
what
just
can
not-
do? It's a tough class, right? So you
That's
have
why I'm
it,
like, you know, if it's gonna, because I don't want to get the bad grade. That's why I'm like thinking if I'm gonna do bad on this quiz as well, so probably I'm just gonna drop the class.
So when is the deadline to drop
I
the
don't
class?
know. I never dropped the classes. I have no clue.
So you have to, I think it's somewhere on the Radical's website, so please check it, right? So when is the deadline? So this is whatever, third week? 28 we started. Oh no, this is just the first week, right? The second week, so you still probably will have time. Okay, I'll let you know as soon as possible. But again, you know, the first quiz, this is just, just
My
you know,
grade
it
is
will
the
be
lowest
5%, 5%, no, it's not the lowest. It's 5% of the level grade. Okay,
And
so
they got like 60,
16, right?
60. I have 12, correct?
Say it again. No. So it's 5% off. So first quiz, right? So all quizzes amount to 30% of total grade, right?
Right.
So we have six quizzes. So each quiz would amount up to 5% of total grade, right? So if you say, if you would, have 20 questions answered correctly, we have 5%. Right?
Okay.
If it's 10, you have 2.5. So it's not that much, right? So there's still a lot of time to, have a, let's put it this way. But I don't know, if you think the course is too hard for you, then we should take it in the fall.
It's what I'm thinking of.
Have more time then.
Because
to work
now
on
I
this.
have more time than I usually have. Because like I can spend like almost the whole day on this, and it's still. I'm just honestly, to be honest with you, I do not understand why do we need this. I'm reading.
This is what accounting today is. Okay.
That's why it just not comes to my
So-
head. That's
okay,
why.
So what? How do you imagine work?
I don't know, but that's such a like a deep details.
Some details. This is a very, very interactive course, actually. Believe me, it's not even close to details. So if you would work as an auditor, or I don't know, even in a big company, you have to know much more. So we have, for example, these ERPs, right? I will discuss them. Well, we'll talk about it, but there is a course on ERP developments which have at Rutgers. Okay, the whole course. Today I will talk about basically developments of such system, right? Life cycle. There's a whole course devoted to this, and we cover this in 15 minutes, 20 minutes. So it's not details at all. Believe me.
Okay, so I'm gonna email to you, or you're just gonna email to me when you have a
I'll email
moment?
to you. Okay.
Thank you.
But you still have to take this course. It's a requirement.
I
So
know.
you can take it in the fall, but I think Professor Kogan will be teaching it. I think he'll be,
Why do you want to
more harsh than me, actually.
Why do you want to drop it?
Still,
I just not probably at the computer. It's not.
this is a required course, so
I know.
if you think you'll have more time in fall to open this, but it will not get easier than that. Okay, so
I'm not
Professor
looking
Kogan
for
will use
the
the same book,
easiest.
the same
I'm
stuff,
I'm not looking for the
It's gonna be
easiest
same
way.
book?
the same book. If you go to New Brunswick, that's this is what this will be very tough. Okay, so for example, here I just use one book. I have a professor who uses 2 books. I have 3 stages in a project. Okay, at least for summer, he would give you 6. So that is one of the toughest course. So you probably would. I think it's the toughest course people take here. Well, so undergraduate in New Brunswick is the toughest course there. So I can tell you that.
Just stick to the class. You'll be fine. What you got in the first quiz?
Not really good.
But still, it was like 5%. I mean, it's not really.
Yeah,
big.
it's not the whole
That's
grade.
why I wanted to know if I'm gonna do that on this as well. That's really what I'm really thinking.
Chapters 3 and 4 were tough. This is true, but I think other are easier. Not as many concepts and all this stuff, but this is a tough course. So if you have never seen it, and most people do, most people here are uncomfortable with this, and I understand this, but this would be your job, more or less.
I know that's.
I think actually this is a problem here in traditional accounting, right? What we teach here, but I think that we teach, we will not use it at all. But this the oldest table for the style. This is where data is right now, where content data is. So
I was gonna show you this one.
no, connection speed significantly higher than
It is
significantly higher than
yeah.
Zen dial-up models.
So it is significantly. So definitely
DSL and
and
ISDN.
cable, they are significantly higher.
All of them. All of them.
But Professor, if you significantly were, you threw me off. Like,
So
'cause if
ISDN
you
would
see-
give it at least more than 2 times. It isn't significantly higher.
not more
speed.
than 2 times. It's like
More than 2. 128 and you have
128.
56K.
Yeah,
So it's
it's
more than
not
2
like,
times. More than 2. If it's 622, it will be 120.
But
Well,
these are like
well,
tricky questions because if you was significantly higher, because I knew like it is gonna give you higher than that. I mean that was for sure. Because also like because they split up into 64 and 64 in the ISDN, because you can use you can have telephone on and also the internet. But these are like tricky questions, so you can. Because it's not like I did
look,
not
this
know
is
about
just one
that.
question, right? So if you have one question, forget about it.
But
It's
if
not
I
a big
keep
deal.
getting one,
Right, but look, I I don't know, find tricky. It's two times, more than 2 times. You could significantly higher. Yeah, I know what you're saying. You say significant, I think maybe is a better word, but I think at least 2 times it is significantly higher.
And also like for this one, this previous type of the dynamic RAM, because because if you compare SD RAM, because they have DDR2, DDR3, and the RD RAM, they just made one which was way like faster than SD RAM, but SD RAM has more types.
So, well, RDRAM actually.
It is faster, but
Actually, I didn't mention this in class, right?
Yeah. Because you
it's
actually
like
kind
a
of
book.
skipped over the RD RAM.
Yes.
It's not even in your slides too.
Yes.
So because I knew in the book it says currently they have DDR3, which is actually faster than RD RAM. So I
Right,
was,
but SDRAM is not DDR3. No, the
but
book
it
says
is
DDR.
SDRAM. Like I mean, it's a type of that, but it originally came from SDRAM.
So what is
A lot of people got that wrong. Not, so I'm not the only one. Like, because I mean, you can like give everybody.
No, this faster. So if you take SDRAM as the original one, right? So of course this faster RDRAM, right?
Yeah, of course. But SDRAM,
DRAM,
makes
so
it
it didn't say DDR3. It says 3 of degree reason. But look, if you'll have something like this, if you're finally great with the band and was 21, I will give you good grades. Don't worry about this. Although technically speaking, in the book itself, it's the best version. Not, well, it's not DDR3.
But I was thinking it's like,
than that.
yeah, because I was thinking like, okay, SDRAM, but it goes into details. So like SDRAM has more types. Because if RDRAM, they just made
It's not
one.
SDRAM, but people call it SDRAM. Yes, since it was
I was thinking like RD, they just made one and then they stopped. So
Yes.
you get that popularity. So.
Because she had money. I knew, bro. Come on. I was trying to tell you. I told you let's run. You don't want to take a walk to university, you have to go by your You could have come back from university. Now we have to suffer for another hour and a half.
Actually, you won't party,
Let's go to that university. I took a basic program. Basic like HTML. So we actually did have to write basic programs. Okay. And I wouldn't have been able to pass it if it wasn't for my mom, because my mom was a computer programmer back before she had me. And then she had me, she never went back to work, and the last language that she programmed was C++. So she doesn't know anything anymore, she can't go back to work.
Well, that's what you do, right? But C++, you can just use it for equals what you need.
Yeah.
So you don't need HTML, right? Well, unless you make websites, right?
Well, yeah, absolutely. That's like web design, right?
C++ is the best language probably.
Okay.
There is at this moment, I would say. There's C sharp, F sharp, right? But they are not as they are more intuitive, easy to use.
Okay.
They are not,
Not as
good.
advanced,
Yeah.
right?
If you write a program in C++, it's the fastest program.
Okay.
But I was just wondering, professors, like, are all like the accounting professors like really in depth with the computer? Of course not. Of course. Oh.
So it's a good department. We have an accounting department. And they have a department of accounting and information systems.
Oh.
So this is my department, right? But of course they are not.
And so
But-
I was like, oh my gosh, all of your professors know this much.
No, this is different. So we have professors who do taxes, right? Professors who do more financials, managerial economics, right? So,
I'll try and remember. I'll try and save some of the programs that I created just to show you what I did in that class.
very good. Yeah. So anyway, let's continue. Right. So SQL. By the way, I think I did tell. Yeah, I did tell you, of course. So we were talking about programming languages, right? So what generation is SQL? Is first, second, third, or fourth? Programming language. Fourth. This is fourth, right? Fourth. Why is it fourth? And what is fourth? Okay, like, what is fourth? Maybe you know why it's fourth. What is fourth? Generation programming language. Depending on the class, you do it, right? So they didn't have it, right? Well, anyway, what is fourth generation programming language? It's a programming language that what? It's basically where you don't tell. Basically, you tell what you want to do, what you want to get, right? Don't tell how it should be done, how it should be carried on, right? Like in SQL, you said, well, get me this and this and this, blah, blah, but you didn't specify, how it's going to be retrieved, how they're going to be merged, and all this stuff. Okay? So you don't have to think about this. Just say what you want to achieve at the end. Okay? So let's look again. So we have this tables, customers, sales, items sold. The question is, which customers do you only have exceeded their credit limit? Okay? So how would you approach this question manually? Suppose you have the sport tables and you have those fields, right? How would you do it manually? Suppose you have small tables, right? Print it out, and you see those tables. So how would you do it? What would you do? How would you answer this question? Manually. You would what? Okay, so you have a customer's table, and in this table you have credit limit, right? Good.
So then, the sales, like the amount of sales.
What does it mean that customer's credit limit exceeds balance? What balance? If he has exceeded his credit limit. Yeah, but okay. So what does it mean in terms of those fields, right? We have fields for each table. What does that mean?
These customer have exceeded their
Yeah. So what does it mean?
They can't borrow anymore from us.
No. Based on this, right? So how would you make?
It's a query.
What you said, right? So what do we? Okay, let me help. Use the first one. So if you take a customer record, right? How can you tell whether the customer has exceeded his credit limit or her credit limit or not? You have a record of a customer, right? You have customer number, name, address, phone, balance, credit limit.
Limit to balance.
Yeah, so you compare credit limit to balance, right? If balance exceeds credit limit, then this customer has exceeded credit limit, right? His or hers. Good. So this is the idea. So how do we write this? well, we'll say first we say select. Okay, we're at select. And we need to say actually let me write it down. So first word is select, right? Then according to this slide, we have to basically first write what fields we want to look at. Okay. So it says which customers, right? So well, we can interpret this in many ways. So one way would be to display customer numbers, for example, right? But suppose we want to have all fields from customers table, right? So we have a record. We want to display all fields from that record. Okay. So we would write something like select customers. This is a table dot. First field, customer number. Customer number. Okay. Comma. Customers. Dot name. So this says, well, show me fields customer number from customers, show me field name from table customers, and basically we would, list all the fields, right? So the last field would be customers dot credit limit. Okay. Good. So basically, first we write what we want to display. So I just said, well, basically we want to display all fields from customers table. Okay. Then we write this keyword where. Oh, I'm sorry, from. Of course, from. If you go back, from should say what tables we will be using, okay, in our query. The table that we use in our query. So what tables we will be using in our query? What tables do we need to answer the query?
Credit balance and credit.
Tables, not fields. Tables. Sales. Okay, why do we need sales?
You want to know how much they spend.
This is balance here in the customers table. So why do I need sales?
Because sales would tell you the balance.
No, balance is here.
So you
Customers table.
need customers.
So I don't need sales, right?
You just
I need just customers. Okay? I need information on customers, which is in the customers table. I need customer balance, which is in the customer table. I need customers credit limit, which is in the customer table. So the only table that I need is customers table. Okay, so write customers. Good. So it says, show me those fields from this table. Okay. And then we don't want all to display fields for all records. We want just some records to display. Okay. What records do you want?
customer balance.
We want records where customer balance what? Is where customer balance is more than credit limit, right? And this is what we write. So we say where customers balance is more than customers balance is more than customers dot credit limit.
And you wouldn't put it just like that in
Where?
access?
Yeah, you can do this. So actually, let me go back. This is a good question. So you can use either this method or you can write query. So this method, you know what it does? Basically, it converts this to a SQL query. Okay.
So we can actually make query.
Yeah, so that you can bypass this. And actually, this is more powerful. You know, if you really want to write powerful queries, you need to know SQL. This may not be enough. Okay. Okay. So this is a query. Okay. Again, let me go over it again. See if you can see it well. So basically, first you write select. First you indicate what fields you want to output. Okay. So you want fields customer number, name, address, phone, balance, credit limit. So you write customers dot customer number. Okay. So this is a table. This is field number, comma, customers dot name, comma, blah 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 blah. Customers dot credit limit. Okay. Then you say what tables you would be using in your query. Well, we need information only from one table, from customers table, right? So we say from customers. Finally, you can filter your records. We don't want to display everything. We want just to display records where customer's balance is greater than customer's credit limit. So you write customer's balance greater than credit limit. Okay? So this is a query. So we can simplify this query in two ways. First of all, well, if we use one table, or if we use even 2 or 3 tables, and the field names are unique, right? Unique. For example, we have balance here, and there is no balance in sales, right? However, customer number is both in customers and sales. So if you have unique fields, for example, balance, which is nowhere in other tables that you're using in your query, okay? So you don't need to write customers, dot. You can just write select customer number, name, credit limit, okay? From customers, from the table, where balance is greater than credit limit, okay? So if basically there are no conflicts with the field names, they are unique, you can write it this way. Moreover, if you want to display all fields from tables that you are using, right? All fields. You just put an asterisk. So if we put an asterisk here, it will display all fields from the table that we are using. If we're using one table, so it will display all fields from customers table, where balance is greater than limit. Okay? Very easy. So this, this would be our query. Select asterisk everything, right? Display everything from customers table, where credit limit is less than balance. This is the same. Balance more than credit limit, or credit limit less than balance of the same statements. Questions? Is it clear more of what?
Let's say
Uh-huh. Okay, yeah, so suppose you want to, so you want to have customers where the credit, that have exceeded the credit limit, and suppose you also want customers where customer number for some reason is greater than 5, right? I don't know why, but suppose we want this. So we would write select everything asterisk from customers table, where credit limit, well, where balance is greater than the credit limit. Okay, and then we would this is additional criteria, say customer number is more than 5, or you can have and credit limit more than $10,000, for example, right? You want to see those customers that have exceeded the credit limit, and where credit limit, their credit limit is very high, something like that. Okay, so Are there questions regarding this? Questions?
Just make a queries and different podcast systems, right?
Yes, yes. So if you use Access, right, they have simplified ways for people to, well, you don't have to know the SQL really well, you can use it. However, it's not as powerful, and it generates a SQL a statement, okay, SQL query. So it's better to know SQL. Good. So this was one example. Let's look at another example. So again, we have 4 tables, the same tables. The question is, what are the names and phone numbers of customers who have been sold merchandise by John Doe, right? So John Doe is apparently is a salesperson, right? So how would you manually deal with that problem? Without SQL, so it's only in words. How would you find those claims and phone numbers?
Customers and sales. Another 2 tables.
So you would use 2 tables, customers and sales. Okay, then what?
Take like name, the salesperson, name, phone, and sales.
So you would look at all records from sales, right?
Salesperson.
Where the salesperson is John Doe, right? From this you can filter all sales records where the name is John Doe, okay? And then you would what?
Get all the names.
And then you would look at customer number for those filtered records. You would go back to this customers table and look at the names and phone numbers of those customers, right? So this would give you all names and phones of customers who was sold merchandise by John Doe. Right? So how do you write this in SQL? Well, the key here, well, it's more complicated than the first case because we use 2 tables. Okay. Whenever you use 2 tables or more, 2, 3, 4, 5, 6, 7, right? And first we have to kind of create a link between them, okay? So we have to link those 2 tables, and we link them in this where statement. So very easy. I'll show you how to do it. So again we have a select, from, and where, right? So what should I write for this select? Select what? Not asterisk. It says name and phone number. So what should we write here? Select. I'm sorry? Yeah, so select a name field from customers table, right? So we say select, let's say customers dot name, okay? Select name field from customers table. Okay, and what else do we need to select? What else do we need to display? Phone number. So customers phone. From, and then we should say what tables we are using. Okay, actually this is a common mistake. Okay, so you would think, right, it makes sense, right? Select customer's name, customer's phone from customers table, right? But this is not where, the table which you want to display. This is a table that we use. So we use 2 tables, right? So we need to put here 2 tables.
From the sales.
From
Like
sales and comma and customers, right? Sales customers. Okay. Now this is interesting. Now, as I told you, first we have to create this link. Okay. We have 2 tables, sales and customers, right? But at this point, we don't have a link between records. So we want to create a link. And the way we create link, we basically say that we use primary key and we use foreign key. So we said that the primary key from customers should be equal to foreign key from sales. Okay, so basically match, records from those two tables by customer name, number. I'm sorry, customer number. So you write something like this. So you create this link by writing where customers customer number equals sales customer number equals sales customer number. Okay, so we kind of match records from those two fields. We'll link them together by saying that those fields should be equal, right? This is information. This is a piece of information, this field, that links the table together. So we should specify this link. Customers.customer number equals sales.customer number. Not sure if you can see. Okay? Now, and then when we create the link, we still have to satisfy this criteria, right? Sold merchandise by John Doe. So we write and. Okay, this is not the only criteria. So this is the first criteria used to link tables. But now we have to leave only those records for which we have customer number. We have the salesperson John Doe, right? So what do we need to write? What do you think? And what? Speak up. Don't be shy. We learn here. It's not the exam, right? Yeah, exactly. So what I just said that we write and where the following condition holds, where from sales table we have a salesperson whose name, should write, this is the name. But basically, salesperson, right, value of this field should equal to John Doe. So, well, let me just click here, easier. Okay, so you can see here. So select display name and phone from customers table. Okay. And we're using tables customers and sales. So we want to match, right, records from those two tables, right? So we want to have a link between them. So where customer number equals customer number from sales, and where this criteria holds, where the salesperson name is John Doe. Question. That's clear. Yes.
Let's say in case you put the sales,
No. So what we could do first, we could write this statement criteria where salesperson equals John Doe, and then customer number equals sales customer number. So it doesn't matter, the order here doesn't matter. Okay. So what's in parentheses? Usually when you have names, this text, right? You put this text in parentheses to indicate this is a text. Okay.
I mean, that last statement right there.
Yes.
Put it under the from. Leave it wrong.
From, what do you mean from?
From. Where we have to take the from Excel and then we put sales person. That will work, right?
No. This is
That's the
after from you just put table names that you use in your SQL statement. Okay. So we used two tables here, customers and sales. So this is why we put it here. Okay. So again, first select. Okay, we say what we want, what fields we want to output. We want to output fields name and phone, from customers table. When we say after from keyword, we say we indicate what tables we use in our query. So we use tables, customers and sales. Finally, we want to have this criteria. The first criteria, so whenever you have two tables, and whenever you want to use information from two tables, first you have to link those tables. Okay? This is how we link them. Customers, customer number equals sales, customer number. And then we also want to have this criteria. Well, the merchandise has been sold by John Doe. Okay? We could have added another criteria, like previously. We could have written and customers dot balance is greater than customers dot credit limit. Okay, this would mean show me names and phone numbers of customers who have been sold merchandise by John Doe, and customers and that have exceeded the credit limit. Okay. So this is how basically this is done. Questions? Guys, questions? Yes.
Why is there a dot after sales? I forgot. Is that to connect sales and customer numbers?
Dot after here, right?
Yeah, why is there?
So whenever you use a field, okay, so you need to put a dot. So so basically this means that this is a field from the table sales. In this case, actually we don't need this, right? We could have written just salesperson. And the reason why, since there would be no conflict, right? So we have two tables. Field salesperson is only in this second table, right? Not as the first one. So we don't actually need here to indicate what table this is. Since it's smart enough to understand that salesperson is from table sales. However, there is another field, customer number, right? We have customer number field in customers table. We have customer number field in sales table. So this is we have to indicate from which tables customer number comes from. Okay, so here you had to write customers dot customer number. So again, we put dot just to to attribute basically a field name to the table. Okay, to say, well, this is a field name field from that table. This is why we put dot. We'll need to put dot if it's obvious. There's no conflict between field names. The field name is unique, right? So for all field names except customer number from these two tables, we don't need to indicate. We don't need to put dot. Since they are unique fields with regards to those two tables. Questions? Let's look at another example. Okay, yeah, something definitely to practice. Okay, so here's another one, even more complicated. So this is as complicated as it will get. Okay. So again, we have the same tables. The question is, what are the names and current balances of customers who have been sold item number 1250? Okay. So what do you think? What should we do? How would you describe this process?
You would look up names and you look up item. You start with name, item balance.
Names and balances are in customers, right? Good. Where do we get the item number?
And you do a query search. Item.
Well, first of all, if you look carefully, right, item number is present in two tables.
Well, the sold one.
One is items, another one is item sold, right?
Items.
Okay.
The straight items, but they're two different.
No, but these are the same. See, there are items here, item number here, right? And what we want really, we want to somehow to connect item number to a customer, right? So the question is, find information about customers who have been sold item number 1250. Okay.
I have a question.
Yes.
You know how there's in bullet point 3 there's item number, and then bullet point 4 there's item number?
Yeah.
Why is there an asterisk next to this one?
Why is it
Because it's from
asterisk?
Yeah, this
It's a foreign key.
is foreign key.
So you see, item number is not by itself is not a primary key, right, of item sold. Item number is a part of a composite key for this table, item sold, right? But item number is a primary key for the items table. This is why we have asterisk. This is a foreign key, basically a field which is a primary key for some other table. Okay. So, and the same with invoice, right? So, as a matter of fact, as I told you, right? So this is a table, and we create this table to model this many-to-many relationship. Whenever you have two tables like this, and you have a composite key which consists of primary keys of these two tables, then you have a many-to-many relationship between those two tables, between sales and items. So relationship is many-to-many, but we'll discuss it later. So anyways, the question is, how do we link customers to item number? Okay. What do you think? Okay, the idea here is that you can match records from tables, right? So before we matched customers and sales previously, right? To match records to connect customer number and sales person, right? To link them. So here, the problem, the trick is that here you need more than two tables to connect item number and customers. Okay. So how do we connect? How do we link them? What do you think? Make a guess. You see, if you take any two tables, right, they won't give you this link, immediate link, direct link between customer number and item number. So, but there is a link between customer number and item number. So, where can we find this link? What do you think? Sales, right? Okay, so basically, the idea is that we can link customers to their sales, right? Yes? Mm-hmm. And then we can link sales through, so how do we link customers and sales? Through customer number, right? Then we can link sales and items sold through invoice number. Okay? So if we link customers to sales and then sales to items sold, we'll have this link between customers and items sold to those customers. Okay? Guys, does it make sense?
Yes.
Okay. So, okay, let me just show you the query. Okay, so first you select. So what you want to display? You want to display customer name and customer balance, right? So it says display what are the names and current balances. So we display name and balances from customers table. Then we have the statement from, right? What tables are we using here in the query? We use customers table, then items sold, not items, items sold, and sales. Oh, by the way, a good question. Why don't we use items sold? Alright, so if the question was what are the names and current balances of customers who have been sold item with description blah blah blah, then we would have to use all things, right? Why? If you need just item number, right? We need just three tables to find to link customers and item number. We need customers, sales, which will link through customer number, and then we'll link sales and items sold through invoice number, right? And from item sold table we can find item number. But if you want to have description of the item, okay, it's not enough. We would also need to link this table to items table through the item number and then look at the description. Okay. But in this case we just need the item number. And the item number we told you we can find by linking customers and sales, and then sales to items sold. So we need how many tables? We need three tables. Okay. So we need customers, then sales, and then items sold, right? Customer, sales, item sold. Okay. So then there is this where statement. Okay. And in where statements we have to do basically two things. First thing is to create these links, right? So we have to link customers with sales and sales with items sold. And what is the other thing that we need to do? This where statement where we basically specify criteria. We also need to what? We need to filter records by what? What procedure?
The item number.
Item number, yeah. So basically, this should be where. So we say select this and this fields from these tables, right? We use these tables. Where now we do the link. Where customer number from customers table and customers number from sales table are equal, and invoice number. So we have just linked customers and sales table. Now we link sales and items sold table. And sales dot invoice number equals items sold dot invoice number, right? Finally, we say and items sold item number equals to 1250. Okay. So okay. If somehow all the information we need will be just in one table, right? One table, very easy. Select what we want to display from one table where you write criteria, where item sold, item number equals 1250. However, what we need is really in this item sold table. And to get to this table, we need to make these links, these connections, right? First we link customers with sales, and then sales with items sold. So this is why we have these two statements. Questions?
Why did you say we can have the item number field on the select?
So why can't we have item number field in select, right? We can, but the question is what are the names and current balances? So it asks you output names and output balances, okay? So it doesn't say output customer number. And select basically means what you want to output. So we say read this as output. Output customer's name and output customer's balance. Okay. Using those tables where we link the tables and item sold item number equals 1250. Question. So these are very actually simple SQL statements, so we won't go beyond this, and this is something that you need to know. Okay. So again, go through it at home. I told you, it's a chapter which you need to read. The best strategy is read chapters at home, try to understand. I'm here. If you don't understand, ask me questions. Okay. I'm not here to tell us the book, right? You can read the book by your own. I'm here to help you out with it. Okay? Questions? So there are other features of database management system. One is backup. Right? So it's important to have a backup of information. Right? So if something happens, well, you want to be able to recover. There are two types of backup. Right? One is static backup. So basically, what you do, you shut off your system and you make a backup of your system. Okay. The other one is you do everything online. Okay, so it's called dynamic backup. So whenever you write new information to the database or change your information, okay? You do it twice. First you do this on this original database, and then you do the same on the backup. So you kind of have this mirrored database, right? So this technology is when you mirror databases or mirror storage, whatever it's called RAID, right? Redundant array of inexpensive disks. Is it here? Oh, it is here. RAID. Okay. So the idea is that, for example, think of data on this computer as a database. So what you can do, you can install not one hard drive, but 2 hard drives. Okay? And you can put them in the mode. So if you write anything to one hard drive, or if you do anything with one hard drive, the same changes would automatically be done to the second hard drive. Okay? So you have kind of 2 hard drives which are mirror of each other. So if one fails, you have the other one. Okay? This is called RAID 1. So if it's your home, you have some sensitive information, this is what I would recommend you to do. So buy 2 hard drives, arrange them as RAID 1. So if one hard drive fails, and hard drives, as I told you, fail, they will fail inevitably, you will have the other one. Okay? So whenever you use this kind of RAID method, it's called dynamic backup. So you do everything on the fly, you do backup on the fly. If you shut everything down and you make a backup of the system, this is called static backup. Of course, dynamic backup is much better, right? It's more expensive, but it's better since you don't have to shut down your business. And sometimes you cannot shut down your business, you cannot stop operations. Questions? Good. So comparative control. So I'll give you this example. So you open a file in Microsoft Word. Right? You try to name the file and you cannot. And the problem is that you cannot write the same file at this moment. Okay? So like the database system, well, there are ways how you can do something about it. So one thing is called lockout. So lockout is a bad thing. The idea is if someone is using the file, you cannot use it. Okay? Which is bad. Another idea is write lock. So if someone is writing, or if someone is editing a file or a table, okay, you still can view it, you can open it, but you cannot really, you cannot write. Okay, you can read it, but you cannot write to it. Okay, it's called write lock. And in Access, there is something like write lock. Okay, so even better systems, more modern systems, they allow you to have this write lock not at the table level, but at the records level. So you have this records, okay. So if you change record, so basically different users can read and write different records. So all users can read all records, but one user can write one record at a time, or one record can be written by one user at a time. Okay? So this is write lock. Questions? Good. So another idea. So now we're talking about the database approach, right? Relational database model, all this stuff. So there's another approach, which is object-oriented approach. So the idea is not to have tables and links. The idea is to have objects. So object would be something that contains both data and both methods. Okay, so as we discussed before. So you kind of have a table and you have embedded things that you can do with this table, right? So there are some procedures that you can do with this table. Okay, so it's called encapsulation, which we discussed before. If you want to create another table, which is another object, which is relevant to the first object, you do this by inheritance. Okay, so this is some concepts which we discussed in chapter 3. Okay, so basically this is for chapter 6. Let me just give you an introduction to chapter 5, 7. Next time I want to finish the chapters once. Okay, we won't go through all the chapter, but we just look at the introduction. And if you have any questions, feel free to ask anytime. So, are there any questions regarding this chapter 6? Very important chapter. You will have to read it again if you haven't already. Sorry. So chapter 6 is basically one of those chapters which you'll be using for your project, and especially chapter 8. But let's talk about chapter 7. Okay, so what do we know so far? Well, we know some concepts related to computers, right? We know how what types are there for information systems, and we know what is a relational database, right? So just start. The question is, well, okay, so suppose I'm convinced that this is the best model of that right now. So how do you implement the system, right? So how do you design and implement the system? This is which we'll discuss in this chapter. So why would you make a new system, right? Well, as I told you, there are some benefits to implementing this new system. And where do the benefits come from? So one reason for those benefits is basically that, well, you have a current system, and the current system is not good enough to meet your needs. Okay, so it's too slow, or it doesn't have some capabilities. It requires a lot of manual intrusion, right? So it's very costly to do this, right? The other reason is, that the technology changes. So although your system works fine as it is right now, but you can cut your costs by implementing this new technology. It will be much more efficient. Okay. Finally, which is a good thing about competition. So if you have companies which compete out there, right? If you have what they call real market, then your competitors may introduce new systems, right? They can lower the cost, they can sell the products at a lower price. So you want to be in the market, you need to compete with them. So you have to basically do better. Okay. This is another reason why we want to implement such a system. Questions? Good. So this lecture will talk primarily about system development life cycle. Okay? Well, there's something much broader notion called systems life cycle. So what is a systems life cycle? Well, this is a life cycle of any system. Okay, and this can be also a biological system, doesn't matter. So any system has some kind of periods in its life. Okay. So first, there's a creation period, right? So while the system is created. Okay, then there is a startup period. We basically have a system, and there are some errors, and you still tune the system to make it a good system. Then there is a maturity period, where the system is primarily used. Okay, at the time. Finally, the system becomes old, and it dies, wasn't old. Okay, so that's replaced. This is this decline period. So there are these 4 periods. What we will do, we will discuss this creation stage, this creation period. Okay. Specifically, we will discuss development life cycle. So, how to develop such a system. So how do we develop this? So previously, in the old days, it happened, right? So computers computed, right? So they realize they can use them to calculate something. For example, so do you know what was the first, primarily, the biggest use of computers? Computers were those huge calculators, right? Or the big rooms, right? It was one computer. So how they were used at the beginning in business? What do you think? what is something that requires a lot of calculations? A lot. No, not much.
Like derivatives.
So again,
Like derivatives.
there were no derivatives at the time. They just started to appear. Okay, so it's more or less new concept. So it had black and Scholes, all the stuff that was 70s, right, or 80s. So not derivatives. So one of the worst thing, right, to calculate business is payroll. That's the same people, okay, and they have to calculate taxes, hours, all this stuff. So lots of calculation. So first computers were used, for payroll. But anyway, what happened that people realized that they need to use computers and they should build some information systems. Okay, and they tried to do it. Unfortunately, what happened that they soon found out that it was a very hard task to do, and some organization is it. Okay, so you can't do it just haphazardly, right? So you need to be organized. You have to have some plan. You have to have some guidelines. Therefore, they developed something called system development lifecycle. This kind of a methodology how to develop a system. So it consists of 5 stages: system analysis, system design, development, implementation, maintenance, and operational maintenance. Okay, so 5 steps. And we'll discuss each of those, and we'll discuss basic design and development in more details. Okay. So first, systems analysis. So what is systems analysis? So the idea is that you have a current system today. So you want to you have some system, or actually you may not have a system. The idea is to understand what are information needs of a user. Okay. This is the system analysis. Then you have system design. Well, once you understand the needs, you want to design such system. Then system development. Well, you create this design, so you have to think how this design would carry on. So you have this development. Then you have to implement this in some actual solution, right? Finally, you have to use the system and to maintain the system. Okay. So who participate in this system development lifecycle? Well, of course, you should have professionals, right? System information professionals that know what they're doing, they know how this information system works. Okay. So given the knowledge that we learn in this course, it's not enough. So you have to know much more. So if you want to be system professional, right? So you have to have a degree in this. Okay. However, end users, like us, accountants, are also very important. Why? Why end users like managers, personnel, accountants, and auditors are important in designing a system? What do you think? So those people are also professionals. You have systems professionals, right? So who know what are systems, right? Probably more than all of us here. Okay. So why do you need end users to develop a system?
Because they're the ones that know what they need.
Of course, yes, they're the ones that know what they need. Exactly, right? So those are people who use the system, and those are people, managers who know how to run business, right? System analyst or designer or programmer may not know how to run business, but end users do, right? This is what they do every day. This is why we need end users. And specifically, why do we need accountants? What do you think? Why do you develop a system, an accounting system? Again, because we know the business. Yeah, we know the business and what? It's not just the business, it's actual business. Not just rules. Okay, rules are one thing, right? But
They know the format.
so what you learn, right, during your 4 years, right, is not just rules, right? It's also you learn what information you need, right? What information is relevant, right? And this is a system that captures, processes, and reports information. So we, in a sense, we are, information professionals. We know what information is relevant, what we need, how to use it, and so on and so on, right? This this is why components are very important in this stage, right? So first of all, we can help design the system. Well, we design this. Then it comes with the users of the information, right? So you will be using this information as a system, as an account, right? And also, you are an auditor, right? You handle an audit, so you have to audit such systems, right? So as your internal auditor, so you can say, well, we have to today there was this example, so rules in the limit, right? So it said, well, no one should exceed the credit limit. Okay, so who's in charge of this? Internal auditors, right? So that's why accountants are very important when developing such a system. This information system is basically what is our field of accounting. Okay. So let's start with this first stage, systems analysis. Again, so the idea is to understand the existing system, understand the user needs, and understand whether we need to create a new system at all. Okay. So first is requirements analysis. So basically, what we want to do, we want to get the knowledge. What is this business? What information does it need? Okay. We want to have this knowledge. So we want to know, well, this business needs this information. Okay. So what do we do? How do we learn what the informational needs of a business? We can do several things. First, you can interview personnel. You can talk to people, so they will probably tell you, well, what they need. And so you basically ask them and the narratives that they talk to you, right? However, those people sometimes they don't know what they need, right? And in many cases, they may lie to you. Okay, so they don't really know whether they're saying the truth or not. And this is something very, very costly. To reduce the cost of interviews, you can do questionnaires. So basically, you create this more or less standard survey questionnaire. You send it out to everyone. You minimize the answers. Confuse with the less reluctant to tell lies. Okay. And basically, then you get the answers, and then you analyze the answers from the questionnaire. Of course, the complexity here is the design of the questionnaire. Usually you do it just once, twice at most. So you have to be very careful with design. You have to write very precise statements, which people would understand unambiguously and so on. So we have interviews, we have questionnaires. Then what you can do, well, you can just observe what other people do. So you work as a tax professional in a company, so I go sit near you, okay, and I'm looking at what you're doing. Okay, and this is another way. So you try to understand what people do, what are their needs. And again, since that's a bad thing, it takes a lot of time, right? And you have to, people who are observers have to understand what people carry on activities are doing, right? And they also have to and the people who are observed, again, they would behave differently when they know that they are observed, right? But this is another thing which you can do. Finally, you can look at, documentation reports, and you can use a. So if you have a company, you have a business, so each business should have documentation for how the business works. Okay? So appendix to the chapter 1 describes how you can create this documentation and flowcharts for things. So you can use those to understand how it works. So what do you think? Which one of those methods to learn about informational needs is the best one?
Observation of activities.
Observation. What else? Well, the truth is that there are no best, okay? So you have to do all of them. So there are no best things, since each of them has drawbacks. Interviews, very costly, people can lie. Questionnaires, people can also lie, maybe to a less extent, but very hard to design questionnaires. they are not as flexible as interviews. Observations. So you watch, you need to understand what other people doing. You will not understand this. A. B. People again may behave differently when they observe. Finally, documents may not show you the whole story, right? So you have to do all of them. So this is the best way to sense this knowledge of the witness. Okay, so once you know basically what people need, then you try to assess. Okay, so you have a system, information system. Is it good? Is it bad? So what are its advantages? Where it is good at, right? Where it outperforms. Where it's bad at. So what are the drawbacks of the system? So this is called systems survey. So again, you talk to people, right? You try to observe things. So you try to understand what's going on. So what are the problems and advantages of the current system? And actually, at this stage, what can happen? You may find out that the users need some functions. They complain, "Oh, the system is bad. We can't do this thing." However, the truth is that the system is fully functional and can do more than users know. So the users are not just educated, or the interface of the system is very complex. It's hard to understand. It's not very user friendly. So maybe you don't need to change the system, or you may want to change it a little bit to make it more, say, user friendly, for example, right? And you may decide, you know what, it's not worthwhile to create a new system. We have already have a decent system. We need to spend money on the new one. Okay, this is system theory. And in general, so after each stage, so we have 5 stages, right? After each stage, you do this feasibility analysis. So you try to understand. Okay, so does it make sense to create a new system? Does it make sense economically, okay, to create such a system? Technically, organizational, and operational and schedule feasibility, right? So in your book, you have these 3 feasibilities, and these are 2 that I added. So let's discuss each of them. So economic feasibility basically means that in terms of money, it makes sense to you to create a new system. Okay. So how do we go about this? What is a good way to think about this? Well, one way is to use the method that you already know. Okay, payback period, calculate net present value, or internal rate of return. Guys, what is a payback period? So basically, this is the amount of time which you need to recover the initial cost, right? Okay. What is a net present value analysis?
Whatever is worth right now.
What is it? Okay, so
Like the value of the dollar.
Count value really like your everything, like you can also like knock down your assets or anything.
so the idea is to look at future inflows and cash flows, right? But future money are not as good as money today, right? So so that's why you have to calculate the cost. Well, basically, you have to calculate the value of future like cash flows and inflows, okay, the sum of this in terms of today's money. Okay, so this is net present value. Finally, what is internal rate of return? What is internal rate of return?
Rate of return is like the
Just gonna get back.
percentage, the interest
This is called cost of capital, right? And this is what kind of interest rate? It's not really interest rate. It's a discount rate, right? And so when you calculate net present value, right? So you have to use this discount rates to discount value of money in the future to today's amount, right? So you use this discount rate, and this is the discount rate which would make the net present value equal to 0. The higher this rate of return is, the more sense it makes to So what is technical feasibility? What do you think? Technical feasibility. So you want to develop a system, right? So at this point, this is still analysis stage, right? So you're this analysis stage, and you know, at least now you have some idea what can be the final product. Okay. So we said that after each stage you have to calculate this feasibility, right? Do this feasibility analysis. One way you would look from the economics perspective, whether it makes sense from terms of money. What do you think is technical feasibility? Easy question. Yes.
Technology available.
Yes, it's technology available, right? So you want to do something, say, very fast in microseconds, right? Is such a technology available? Even if you have lots of money and you're ready to invest in it, well, maybe you still have to wait 20 years before such technology will be available. Of course. So organizational feasibility is more tricky thing. Okay? So let me explain what it is. So whenever you want to implement a new system, you may do some radical changes. Changes that many people are not ready for. Okay, so if we use this modern AIS, basically we bypass many things that were done manually before, right? So you don't need now probably as many people, as many employees, right? And you have to change your business process. You will do things different. And so organizational feasibility basically tells you when it makes sense to use these changes to the way you organize your business or not. Well, usually it does. The problem would be if there's this reluctancy of many employees to do this. Okay? So people who don't like change and people don't have some good work, good position, right? Will be as privileged as they were before, or maybe will lose a job, and then will be big gains in this, right? So this is something to take into account whenever we do this, implement such a system. And then I would edit another two, I think more than that. One is operational feasibility, okay? So from the performance, it doesn't make sense to implement such system from the performance, right? Maybe this will be a better system, but it won't again add much to how your business operates. Okay? Nothing will change much. Maybe it doesn't make sense. Finally, maybe it makes sense to wait 1 or 2 years, see what other people would do, and then introduce another system, modified system, right? And to invest money right now. Finally, schedule feasibility. Suppose you want to implement a system, okay, but we exist, so you will earn a lot of money, but it will take 10 years to make such a system. Does it make sense? Maybe yes, maybe no. Who knows? So you have to take into account how much time it will take to implement such a system. Okay. Actually, this is interesting one. So have you heard of this Hershey's ERP implementation? No, Hershey's, right? So they sell chocolate. So the last something when they wanted to implement ERP system. So the idea was that basically, there was this 2K right problem, which we discussed, Millennium problem, right? 2,000 years. So Hershey's decided to convert to ERP design before this 2K problem. Okay, so they figured out that why would we spend all the money on this, correcting these old mistakes? They can make a new system and everything will be great. The problem was, however, that it takes time to develop such a system. So they planned to implement the system before year 2000. Okay, but it wasn't ready yet. So they really had to rush it. I think they used SAP or something, SAP. And so they wanted to rush it. Okay, and so once the system available when it became online, they made the sudden switch to talk about this later. Small story. So they make a sudden switch. So for example, today you are using the old system, tomorrow we switch to a new one. Okay? Sharp pattern, right? So they made this sudden switch to a new system, and the system fails. It fails and they lose lots and lots of money. Especially given that they just switched just before this 2000. They switched I think in August or something. But during that time, they get the most orders. So why do Hershey's get the most orders in summer time? These are each orders for what? For Thanksgiving and for Christmas, okay? So they got these pre-orders all this stuff. So the people make orders before, right? Yeah, it takes time.
Is it like forecasting, or is it like they actually get the order?
Sorry?
Is it like forecasting, or they actually get the order?
No, they get the orders. Okay. So anyway, what happened is that they decided to rush this. Okay, they didn't estimate the time frame, and they lost a lot of money. I will look up and tell you how much exactly. So this is important. Here you can see basically how you calculate this net present value and IRR. So how do you calculate those? Do you remember? Guys, how do you calculate net present value?
Net present value?
Yes.
Future value divided by 1 plus R times T.
Okay. So you have a sum of cash flows, right? So here, let's say R, right? R T divided by what? By
What? Sorry?
1 plus present value.
1 plus
Interest rate.
interest rate, discount rate, right? So it's R, and to the power of T, right?
Intangible periods.
Okay, so this is basically a formula for net present value. So they show you how to calculate this. So you have this cash flows, right? One for each period. So first you spend $10,000, and then you get those benefits: 2,300, 3,200, 4,400, 4,800, and you calculate this net present value using these formulas. So if you want to calculate this IRR, you find such interest or discount rate at which this is equal to 0, which is 15.2%. Okay, so this is regarding this economic feasibility analysis. Okay, so I think it's your target right now. So let's start with this point. Okay. Okay. So next time, remember homework, quiz, and you have to email me group composition. Okay.
That's a for the quiz, like after 6 solution and a quiz of the relation, what's my relation?
Can't help.
Yes, you can. You just choose not to.
Well, if I tell you what will be, right, or won't be, you won't read this. Right? This is why we do tests. Why we do tests, we do some random questions. Okay? If you know this, that you know everything. The assumption here. So, did everybody give me the quizzes number 1?
Sorry. Figure out how to
Connect.
to connect.
But at least one huge lecture is missing, so very important one. time there will be a lecture next Tuesday.
Yes.
But then, as I told you, there will be no lecture next Thursday, right?
Yeah, you just use this computer. I can use join me. They
Oh, but
Use
you need to
Germany.
bring the microphone here, right?
no. I think use this microphone is here is very good. Our students use this computer.
I don't think so. I don't think so. No, I sometimes I walk near the clock. Okay, I don't stay here all the time. So I walk
Oh, okay.
in the classroom.
Okay.
So it
Yeah,
won't
I
work.
will next time. I will bring the microphone here.
Okay.